Welcome back. So now let's see who has answered properly the question. And I can see several people are mentioning the QI deck. But so there has been several people mentioning this, but in this case, I think I'm going to give the correct answer to Alexander Warkers because he mentioned completely the name QI 1.2 Charger deck. So congratulations, Alexander, you won the Crazy Fly package. Excellent. Then now let's go to the next presentation. So today, what I would like to say is that we constantly hear about humanoid robots. Humanoid robot here, humanoid robot there. Many big players, they are also entering into the field, like Tesla or Unitree. And the question that we should ask is, why are humanoid robots so important? What can humanoid robots do? And what does it take to be a robotics developer working with humanoid robots? In order to answer those questions, we have here couple of people from the PAL Robotics company, which is a humanoid robots company with more than 20 years experience. Then Luca Marchionni and Sai Kishor, they are both members of PAL Robotics. Luca Marchionni is the CTO of PAL Robotics, and Sai Kishor is a senior robotics developer from PAL Robotics. So today we are going to ask him a lot of questions. Thank you for coming, Luca and Sai.
Hi, nice to meet you, everybody.
Thanks for the invitation.
Yes, so we are very excited to have you here. Even we have some troublesome, but we have already solved. And then especially for this interview, I think that is going to be easy peasy here, especially with your experience. By the way, so your company, PAL Robotics, has 2 nominees on the ROS Awards of this year, right?
Yeah, one was a surprise, but
yeah, one is which one is the robot, right?
Yes, Tiago robot.
Tiago robot, and the other one is you. is the man. He's the man. So you are 2 nominees. Excellent. So we'll see that, but we cannot tell you who is the winner on both categories until the end of the conference. So far, let me ask you some questions about the company, PAL Robotics itself, because I think that the audience are interested on those humanoid robots companies. So which type of robots do you build at PAL Robotics, Luca?
At PAL, we build many different types of robots, from mobile bases up to humanoid robots. The company started more than 20 years ago. This year is 20 years old, the company. We started as a research and development project around the humanoid robots, and then the company grew, and now we have many different type of robots and services that we offer. The company is organized in different business units. Intralogistics for more industrial purposes, with Stockbot for inventory taking in retail. We have mobile bases too in this business unit. Then we have everything related to mobile manipulation. So the Tiago family of robots with 1 manipulator or 2, and even 3. And then we have the legged business unit, in which we serve mostly R&D market, universities or research center that want to start doing research or continue doing research with a commercial platform. So we offer not only the hardware, but also the software and services maintenance to keep them up with the research they want to do on legged system.
So for humanoid robots, would you say that most of the business is in research?
Yeah,
for present?
Especially for humanoid robots, most of the customers that we have, and even the customers that ask us about the possibility, even if there is a small shift in the recent year. So there are interest from great industrial companies about testing, evaluating, and assessing the potential of using for real this robot in production line, in factories, but still most of these type are really like are pilots, are more tests in more or less real environment, but still there is a lot of work to do to deploy complex robot as a humanoid robot in a production line.
I see. And then can you tell us, just as a secret, now that nobody is listening, any robot that you are building right now?
Sure.
I mean, some of the latest ones that are about to be released or something.
Well, we are currently working on Kangaroo. It's a new bipedal platform that with a more innovative technology that we built. Everything of Kangaroo is built in-house, right from motors, motor control boards, even the design. And it's pretty innovative that in order to squat, usually every humanoid needs 3 motors to actuate. But our Kangaroo can do it with only 1 motor.
Wow.
Yeah, and also we are one of the products we are working on is Tiago Pro with the new series elastic actuation. So you can also have the torque control. You can also have more dynamical control on the robot.
But that is a new version of Tiago, or is an upgrade of the existing one?
Yes.
An upgrade.
It's an upgrade. Plus, it's a completely new design, new electronics, and pretty much it's a better version.
It's like a version 2.0 or 3.0, something like that. Okay. And then what? Now that I'm talking to you, Sai, so what sparked your interest to work in these kinds of robots?
Well, I was always fascinated about robots from childhood. From childhood. But then once I started back in 2015, I visited PAL Robotics. I saw them, their website, their robots, it's cool. So I dropped them a couple of emails that I really wanted to visit. When I saw the Ream that day, it completely blew my mind. That's when I decided that I wanted to pursue this passion.
Nice. And how long have you been there already working?
It's been 7 years.
7 years already. Wow, awesome. And what?
This September I'll be finishing 7 years.
Awesome. And what about you, Luca? So what sparked your interest in working for developing humanoid robots?
I've been always fascinated by technology in general, since when I was a child, watching movies about Star Wars, droids, artificial intelligence. And then when I started engineering at the faculty in Italy, I had I was lucky enough to start working in a team that participated in RoboCup. So I started learning Linux, C++ programming, and hardware, laser. There were times where SLAM was still an open problem, so we started looking at how to build a map, navigate autonomously, and I get into that world, and then I didn't come out. So,
but then in that case, it was in general sense of robotics, right? Not on humanoid robots specifically.
Yeah, it was a general robotics, mostly, let's say, computer science.
Yes.
Then I entered a few companies before joining PAL Robotics, trying to look for my place in the world. And then when I discovered this company, PAL Robotics, that they were doing humanoids, it was love at first sight. I started together with you as a software engineer in the navigation team. Then I started getting more involved into control, balancing for walking, motion planning, a little bit more also on the hardware side, supervising some development about actuators and so on. And now I supervise a little bit of everything about new projects, new system, new robots, trying to coordinate between the different teams that we have in the company.
Awesome. But then, in order to get into that path, so which kind of education did you follow, Sai?
Usually, it's better to have a master's degree or a PhD. And
in which?
In automatic control and robotics.
For example?
Yeah, control and robotics, basic. So it's better you know a bit of kinematics and dynamics, plus a good programming would help a lot for sure. And a hands-on experience on different hardware really helps.
And in your case?
I studied engineering, control system engineering also, both the bachelor and then the master. I started a couple of PhDs, but then I dropped because I was too busy. Too busy.
Yes, I remember when you started the first one, and you were like this of work, and then you wanted to do the PhD, and it was crazy.
So no, I think engineering for sure. Then you need to have quite good math understanding, and for sure, especially for Sai and me that are more related to whatever is control, actuation. Sensor calibration, you need to have a good understanding of control system. We end up at the end managing sensor and motors, and you have to make things work together. So that is a good background. And then also I think it's important to know dynamics, so a little bit of physics. At the end you have a mechanical system. This is a rigid body. you need to know about how to control this system in the world. So everything that is more defining the robot as a mathematical model, controlling it, and giving it also some simulation to validate the idea before testing it on the robot. So simulation for sure is part of our daily job.
And I would add also analyzing a bit of statistical data helps because when you do an experiment, you record a lot of statistical information, and when you look at it, you really need to know which is the root cause of your issue.
By gathering the data and then doing an analysis, applying different techniques. And do you think now that nowadays having a degree is also that important? Because you have mentioned about knowledge, but not about the degree itself. So those degrees in those times, they provided this knowledge, but now there are many other ways of. What do you think about? Do you think that having the actual degree by a specific university or entity is that important in getting a job in humanoid robots? Okay, I'm specifying in humanoid robots because it's the subject. What do you think?
I mean, the truth is that I think, I mean, at least personally, many of the things that I studied in the university, I at least use them, apply in derivatives, integrals, or and differential equation. It can be strange, but it's true that sometimes we need to have that knowledge.
Yeah.
Then I think that the university, especially for me, helped a lot building the modus operandi. So you need to reach a goal, and you need to
Follow some steps.
Step by step. So there is nothing that can be done immediately. So you need to understand, okay, analyze the situation, understand what could be a possible reason for something that is not working, prepare a plan. So step by step, like an exam, no? So you have the date of the exam, but you need to study 3-6 months before to arrive to that point at least with some probability to pass the exam. And I think it's the same that I think then that type of modus operandi or let's say can be not only learned in a university. So it depends a lot also on the character, on the personality of a person, on the attitude, on how much energy and how much interest everybody puts in what he's doing. So that is the important part. So some universities, and they are not all the same, no? So you can do engineering in one university or in another, and there is a lot of difference. So I think that especially depends on even very few, variable that you cannot control. The professor that teach you robotics, if it's a very charming person, can make you fall in love for something, and then you start. Okay, I want to be like this.
Exactly.
Or maybe a group of friends and students that you do that can also shape the way you start doing outside also the university. So I think that many factors can influence the path, and especially I think that most important that you need to figure out what you like to do. Because every career has its own difficulties and steps or obstacles to overtake. And robotics is nice because there are many problems to solve. So
Yes.
if you like problems, probably robotics could be a good career.
And hard problems and difficult problems.
I also say that enthusiasm is a good friend. You know? So you should also have enthusiasm, because sometimes what you learn in the university, it's limited, and you need to have an enthusiasm to go a bit beyond sometimes, and that helps. And only a university degree is needed, as Luca pointed out. You need to know the step-by-step process, because if not, it's like you won't understand what's going on, and it's a trial and error method. At some point, you're going to achieve, but how fast you achieve is the difference.
Yes. So it's kind of speeding up your process.
Yes.
And okay.
But it is needed.
And are you asking, when you are hiring, are you asking for a degree in the candidates in general?
It is true that the job offer will normally specify a degree in computer science or electronics or mechanics, depending on the position. But it's true that normally there is this like a requirement. Is it true?
Yes.
But it is also true that sometimes if you have comparable experience, you can have. It's not something that then, I mean, we put it in the job offer,
Yeah.
but then we don't do screening on the curriculum based on that. So,
Never. It's just an offer, and then based on that
because I think that actually the sentence that we use normally is bachelor or master degree, whatever, or equivalent experience. So that is
correct.
the sentence that normally we use for also encourage people that they don't have a specific degree to also apply if they think that they match
exactly,
the
they
job
have.
description. At the end, it's more important what you are able to do
Yeah, exactly.
than what you study.
I agree.
It's,
Exactly. Okay, I wanted to clarify this point because for the audience, this is a very difficult point. Because they are trying to decide, how to get into this, and then should I get a degree? Then with you providing this information, they can make a better informed decision about whether going to your career by doing things and working in different, starting from very low, for example, and getting this experience that you mentioned, or doing projects, or going to university, but in a good university, to a good university, and do and be very focused on that, on learning this material. So that's very clarifying. Okay, then let me see here other questions. Then what about Sai? So can you describe, as a humanoid robotics developer, so can you describe a typical day of work?
Well, typical day of work, we sit down with Luca and other colleagues, and we decide. I mean, we go through the problems that we have and how to approach it, and we try to come up with each and every solution, and try to go with which is the most optimal one. And along with that, Luca, we might also have electronic issues and mechanical issues. We ask Luca because he is the CTO of the company, and he will be dealing with the other teams as well. So he is the main coordinator between all of us.
Yes, as the CTO
Yes.
job, exactly. So basically, your let's say your 80% of your job is to be working on solving engineering problems, right?
Yes.
That would be that's it. I mean,
Yes.
this is very important for the audience
Yeah,
because
yeah.
they want to know. That's why I'm asking you. So I'm going to work on, and then I'm going to be on this meeting in the morning. There's the other meeting.
No.
Then I have to coordinate these people. So I don't know. What I want to do is to solve humanoid robots. So that's what you're doing.
In that case, I'm very happy to have Luca at that point because most of the times we try to avoid unnecessary meetings. Like I see a couple of my friends having a lot of meetings than doing actual work, but usually we tend to do more work, and maybe per week we'll have 2 or 3 hours of meetings. That's it, per week.
Per week. Okay, lucky you. So cool. No, that's very cool. That's how it has to be. That has to be, and then that's awesome. This is awesome. And let me say, so how is your team structure? So do you have like a hierarchical way on your team, or you have more a flat way? How do you work together in order to solve the problems?
It is a bit hierarchical. Of course, we all report to Luca, and with Luca we have a team leaders, and the team leaders have a particular team, and it's not sometimes the teams are very structured horizontal and vertical. So we work with per robot, and also our team is called control team, and we deal with also humanoids, mobile bases, as well as mobile manipulators. So mostly mobile manipulators and humanoids. And the mobile manipulators, we tend to we have a separate 2-3 people group. They work especially on the mobile manipulators, and a part of our team completely works on humanoids.
Okay. Also trying to give a sense to the audience about how, if they work in a similar company, how would be their colleagues and their day-to-day basis. That's why it's important. And can you share a recent project that you have been working on a problem that you are trying to solve but still not solved? If it's not secret, something not secret, okay?
No, I mean, because we just came back from a delivery of our first kangaroo to a university in Austria.
Okay.
And it's fun because you will go, you arrive in Austria at the airport, at the duty free, and everywhere is no kangaroos in Austria. and we were delivering a robot that is called Kangaroo. So we were like very, okay, so now we have to change this. So,
So now exactly now there is a kangaroo in Austria.
now we can say that there is a kangaroo, at least one kangaroo in Austria. Yes.
Yes, exactly. I think that this is a very good marketing for your.
Yeah, no, it was a very, let's say, this is like the first customer that bought a kangaroo robot that is this new agile humanoid robot that we have been developing for the last almost 3 years. And it's a new, let's say, concept of actuation with really built up from scratch every component of the robot. So it's quite interesting as a as a legged platform because it's has some unique points in terms of motion. For the legs, we pointed to everything is made with linear actuators instead of rotary actuators like traditional, let's say, robots. It's a platform that is very robust and is meant for agile locomotion, jumping, running, and also it's let's say it's very the design we decided to keep it very rough,
Simple.
simple for having a robot that is easy to use for researchers. Because we come from the experience of having built many generations of different humanoid robots, and one of the difficulties that we have when you deliver a robot like this to a university, they need a lot of infrastructure, they need a ceiling crane, they need 2-3 people for dealing with the robot, doing experiment. If the robot falls down, it's a very a mess because can break everything. So the kangaroo is a little bit trying to reduce the entry barrier for doing research in leg and locomotion with a robot that is capable, is a human size, but for the moment is only leg and a torso, but there is also already the possibility that we are foreseeing to add arms to the robot. And the robot is quite lightweight because for the moment it's about 40 kilograms. And it's, let's say, it's easy to handle. Much easier than Talos robot, that is the other big guy that we have been selling for research in humanoid robotics.
And then this robot, for example, has a system that prevents it from falling. Because
there are several levels of safety for sure about, okay, you can still use, we normally suggest to use the crane. But there are also some features that we added on the robot that make it more robust. So all the motors of the robot, for instance, are around the waist, and we added to the robot a protective belt around this motor so that in case of a fall, the electronics and the motor should be protected. Also in the torso, there are some flexible materials that we added that should absorb the energy of the impact without damaging the electronics, the computer, or the battery. So this is the idea. Awesome. Then many things need to be still solved, and actually this was a little bit now the end of the story. It actually is the beginning of the story. Now with the first delivery, it's just the completion of a first important milestone for us because we have been working very hard in the last 6 months because there is a lot of things to do in terms of control and behaviors for this type of robot. Even the simulation is complicated because this robot has many closed kinematic chains.
And then Gazebo
doesn't support them so well, so we started also looking at alternative simulators. We started improving our own simulator. We started using Mujogo. We started using Isaac Gym. We started looking at reinforcement learning for learning from scratch walking for this type of robots. And we started modeling all the small parts of this robot that when you want to model it for complete is 76 degrees of freedom, only the legs.
Wow.
So it's like 6 times more complex than a typical 12 degrees of freedom robot. The benefit is that thanks to this closed kinematic chain, we have a very lightweight and an agile leg. The leg is minimal. You have no electronics, no motors. Everything is moved up in the torso. So it makes more easy to control using a simple model like the inverted pendulum or so on.
Almost passive. Yeah. Almost a passive walker, right?
So there are, let's say, from technology point of view, is a great advancement. It's true that from control and software point of view, there are many challenges to be solved yet. But we are very, let's say, we are busy. We are happy and busy, let's say.
Okay. Yes, I can see. Wow. Well, but you put a lot of stuff there on the table, and we don't have the time to talk about this. We need 2 more hours. Okay. Let me So for the guy, I'm pretty sure that the audience there is super interested because you throw about the different simulators, the reinforcement learning for the, my God. But let me go to another question that is on the script. Okay, so it's what set of programming skills, physics, mathematical skills are required for developing the Kangaroo, for example?
Well, as we mentioned earlier, you need to know the basic physics, the kinematics of the robot, Jacobians, what is a basic Jacobian at least, and you need to know a good programming skill in C++ at least, because at PAL we do 90 to 95% of our code in C++ to have the real-timeness on the robot. Because for instance, Talos and Kangaroo run at 2 kilohertz control loop frequency.
In real time?
Yeah, in real time. Along with that, some strong background in mathematics, differentiations, and also it's also good to know the new technologies that are being, like for instance MPC, optimization techniques, because you also form a lot of optimization problems on the robot and you solve them. Either it could be hierarchical or weighted optimizations, etc.
Yeah, for this kind of robots, you are more focused on modeling and control, right? Rather than, for example, higher level skills like navigation or manipulation, right?
I mean, yes and no, because actually the good part of the software architecture that we have on the robot allow us to use a lot of software from the different robots. So already on Talos, we started doing navigation. So we have, on top of the basic, let's say, step planner that plans the step where the foot of the robot should land, we added some perception, so the robot is able to build an elevation map, identify planes or regions where the robot can put the foot, and then so define, okay, an endpoint, you want to go to that point, and the robot is able to generate a list of steps and also plan online in case that something changes, is an obstacle moves or something new gets into the scene, the robot is able to modify the step. That was already done on Talos last year, more or less. And now even the walking algorithm that we are using on Kangaroo is exactly derived from the Talos algorithm. So we changed the low level because of the different hardware, but given the benefit of using ROS controller or this, let's say, framework that allow us to abstract the hardware, we can reuse the same controllers for walking or for higher level task. So the goal of the Kangaroo project then is to leverage the same planning and perception algorithm of Talos, even going beyond that, because thanks to the lighter structure and more dynamic behavior that Kangaroo can do, basically we want to do more stuff, more dynamics. So we want to have a robot stepping on stones or maybe jumping, and so I mean the inspiration of Kangaroo, I mean, it's not very difficult to imagine, but it was we were amazed by Atlas from Boston Dynamics, and we wanted to do an electric robot able to do similar stuff. So parkour, jumping on boxes, moving on inclined surface, and be very, very agile in this sense.
Awesome. And then, so we'll put some links. Do you have videos about that? We'll put some links on the...
We have some videos.
Okay, so we'll ask you those and put some links on the when this video is published, this interview.
No, actually, this year we plan to go to ROSCON in Odense with the Kangaroo.
Bring it. Oh, awesome. And it's very important that you mentioned that this robot works on ROS, right?
Yeah.
On ROS to control?
Yeah.
Yep.
Oh, ROS to control with in real time then.
Yep.
Right now it's with ROS1, the humanoids.
But,
okay. We are migrating them. We are expecting it in the next couple of weeks or months. Yeah.
Okay. So then for a humanoid robots company, ROS is an important skill also.
Yeah.
Yeah, I mean, that's the reason we are making a lot of effort in also adding new features to ROS to control along these months, so that we really wanted to have these features on the humanoids.
Okay, excellent.
And especially for us, it's important now to deliver something stable to customers. So for this reason, Sai did a lot of effort trying to push as much as possible new feature that then had to be merged in Humble and in ROS2. And we are still thinking about if moving to rolling or not, but so we have an active role, let's say, at least in the part related to ROS control, that is the critical part for us, the one dealing with motor, sensor, and the real-time controllers.
Which is the basic functioning of the robot. Without this, you don't have anything. Okay, let me switch to another topic. It's about the future, so or the current trends. So your robot seems kind of very futuristic. I mean, like the last in the technologies in order to have a modern humanoid robot that is, as you mentioned, is a lot easier to manage, but also more able to move into real environments, which was one of the limitations of the past humanoid robot. So which tendencies, which trends do you see in humanoid robots? It's going into the direction that you have mentioned, or is something else that is in the future people are working already in those technologies?
I mean, the trends, I mean, now there is a lot of interest in humanoid robotics, no?
Why?
I mean, because there is a lot of money that is being injected in many companies.
Why?
And startups. Probably because of Elon Musk effect.
Okay. Okay, yeah, you said something interesting. Yeah, because I mean, so I worked with him for many years already, so I know about that. And then we were doing humanoid robots, and then
nobody cared about
nobody cared about it. And everybody said that was stupid. For what do you want a humanoid robot when you can have, you don't need a humanoid robot, you can have the Roomba cleaning and that.
Special robot for each application.
For each application, exactly.
Now everybody is saying general purpose.
General purpose robot.
General purpose. Okay, so now you come and yeah, so that's stupid.
No, I mean, I know. I think that from one side there is all the let's say what the artificial intelligence hype awake in like now everybody thinks that the artificial intelligence is going to conquer the world.
Yes. Yes.
So that gives some more confidence that an artificial intelligence can exploit a humanoid robot at its maximum performance.
Yes.
So I think that I mean, from one side that for sure helps. I mean, if now artificial intelligence is able to replace, I don't know, many automation jobs, no? Probably also the fantasy about having a robot with the shape of a human, able to use the human tools in a human environment and so on, it's more, I don't know,
appealing, right?
Yeah, more okay. Maybe they are not so crazy.
So exactly, so crazy idea. Okay.
And then I mean, when I think when Elon Musk start saying something, everybody, I don't know.
Is listening and saying, "Oh, that's very so clever, guy. Nobody thought about that before you." Yeah. So one final question. We still have here, but we are running out of time. So let me ask you one. What do you think about the large language models and its effect in robotics development?
Well, it's not going to solve. It's only the language model at the end of the day. So maybe what it's going to replace is the state machines and the behavior trees that we inject in between, the high-level behaviors. It's going to replace that part, because before we have the speech detection and then understanding and natural language processing, and then understanding it to formulate the problem,
to understand the context.
Exactly. So that's a huge part. I mean, we as I said, it's many steps and it's a huge computational part as well. And LLMs are pretty simple. So it's like, okay, get me something. So it understands and it can formulate these things. It helps us to avoid this programming part.
Yeah.
And for developers?
For developers, for sure. I mean, there are Copilot, and
yes,
there are very many, even the ChatGPT integrations into the IDEs. It does hamper the performance of the developers. I would say yes.
So you are using it?
Yes, we do.
He's using it.
Yeah, no, we decided to, as a company.
Okay.
So we have. No, we decided. I mean,
no, because we are doing a test phase right now, and also what you need to understand how to use it. It's just a tool.
Yes.
It's not going to replace anything.
Yes, that's
so
right.
So if you know how to use it as a tool, it's going to amplify your performance at least 50%.
Yes,
but if you're asking it to solve everything, that's not the way it
yes, okay. Very good point. Very well stated. Yes, okay. Okay, then, guys, thank you very much for coming here and sharing so much knowledge and so much advice for the audience. Thank you very much. And now it's time for the audience to ask questions to Sai and Luca. So you know that there is a Q&A tab beside the chat where you can put your questions or ask the questions, or both the questions that have been asked there. And I will move those questions to him. So we have one from, Sebastian Castro. Hello, Sebastian. Sebastian, your old friend. And also start to warm up because you are about to come to the stage also. So Sebastian is one of the most voted here. He says, it seems that robots have very few public educational resources compared to other types of robots, like wheel, manipulators, etc. Do you have any recommendations for where to learn some of the specific for kinematics, dynamics, planning, control for such robots that make contact with the environment to locomote?
No, it's true that it's more difficult now.
Yeah, it is pretty difficult. I mean, there are pretty particular courses in Coursera about the kinematics and dynamics, and also some model predictive control, but they're not centered around humanoids. That's true.
I mean, there is, I think, I remember there is in ROS Drake a course about dynamic, MPC, and Drake, basically.
Yes.
That was quite good. And also, I think from Carnegie Mellon University, there is a quite good curricula of classes about, they build it, I think, from the experience on DRC with the Atlas. Mm-hmm. So from QPs to dynamics to simulation, it was quite good. And then also, I mean, I remember that when I started with Davide in PAL, he also passed me a very good Japanese website in which there were basically all the literature about walking. Wow. And also some tutorials and example of code to run in MATLAB or C++ for at least for the walking as well.
Yeah. And also there are papers from Kajita.
Yes,
and that helps a lot. I mean, that's the basic starting point.
I remember to have actually bought there is a nice book from Kajita.
Yes.
That was only published in Japan for many years. And then there is a French edition.
Remember that you have this one.
Yeah, I bought it. Yeah. So there is this I think it's very I mean, there are very few books about legged robots, and this one from Kajita is very nice because it goes from the kinematics up to the motion planning.
Yes.
Wow. Nice. Awesome. But also a small business here for the construct. Okay. So do we have time for one more question? Okay. Then let me go to the next most voted. Is Hussein Emre that says, what is the benefit of using humanoid robots? For example, a wheel ground vehicle can be used for many applications without voluntary uses. Of course, there is a niche advantages, but it's cost-effective solution.
I mean, in my point of view, you should be curious to explore. I mean, even the wheel robot that we're talking about right now, a few years back, we never thought it is needed to solve it, you know, because the human cost at that point of time is cheaper. In that part, for now, when we explore the options and when we are able to solve the problems because of the curiosity, then maybe it can get cheaper or something like that.
Okay. And what do you think?
It's true that wheels can work most of the time. Yeah. The problem is when you have stairs, when you have cables around, when you have
real environment.
Yeah, so
it's for limit in real situations. It's very limited.
No, and also for wheel, it needs to be pretty structured.
And
yes,
then
it's very
there is also then maybe it's too simplistic, but there is always the footprint, no? So 2 feet of a robot are much smaller than 4, 2, 3, whatever wheels a robot can have.
Exactly, that's true.
So in terms of, let's say, space used for balancing, for sure the bipedal architecture is the most effective. Then it is true that it's most complicated. It's more complicated. It's more expensive at the moment compared to 2 wheels. 2 legs are 10 times more expensive. But I think that this also is gonna decrease the difference
as we move. Yes, exactly. Okay, then I think that we have to finish. Do we have time for? Okay, one more. Let's go. One more. Do you have time? Yes. Okay. Then Jacomina says, Johanna says, any advice on how to get to know into the humanoid robotics field? How to get known into the humanoid robotics field? What would you be looking for when hiring someone?
experience with hardware, that also for sure helps, because it's, very important to understand the limitation or the difficulties to, calibration or sensors, and then also I think, programming for sure. That is a basic, experience, good programming skills, and especially experience with physics simulators, I would say.
Yes.
So.
And now that you mentioned the programming skills, let me enlarge a little bit the question. So what do you think about Rust language?
I started looking at it from a little bit far. It seems interesting. I don't know how fast it's gonna spread into the community. The promises are very good, no? Something that a compilation time, it basically solve all the problems that we have been having with C++ for many years.
Yes.
But it's true that I don't know. It's always a matter at the end of how many libraries, how easy it is to integrate. So it's that then the difficulties are not only learning a new program.
A new program, yeah.
It's how many libraries I can use in Rust today.
Uh-huh.
How
Yes.
can I can mix C++ and Rust? What's the right language for each specific problem?
As a company, we have to be practical. At the end of
Yes,
the day.
exactly. Yeah, I didn't think about that, but that is true. That is a problem that is lacking. Some, for example, even in Rust 2, not everything is supported in Rust 2 with Rust.
Yes.
So just in case that you want to know more, we have a talk about Rust 2 with Rust later today in the conference. So, and you are invited, of course.
Thank you.
You are VIP. So, okay. So that's it. Thank you very much, Sai and Luca. Thank you very much. And now, please take a moment. It's going to appear it's going to appear on the chat form where you can vote for the experience with Luca and Sai. And remember that we will have final, at the end of the conference, we will select the best speakers of the conference. So vote and rate this presentation. Thank you very much. And while in the meantime, that Luca and Sai, they go, so we are going to do something else here here. So Rodrigo, what do we have here? What is next?
All right, everyone. We've had an amazing session so far. I hope you're all enjoying it and finding it insightful. Thank you very much to our guests for coming to speak with Ricardo today. And I hope you're really finding it, enjoying it, and insightful.
So now let's have some time to take a short break. So we will have a 15-minute coffee break now.
But wait, this isn't just any ordinary break.
Huh?
Why is
What
that?
Oh,
We're gonna have an exciting robot contest, which is the Limo Challenge.
Wow.
All right?
yes. Okay. The Limo Pro robot is a ROS2 mobile robot platform that integrates NVIDIA Ori Nano alongside a LiDAR, an IMU, and a depth camera. Limo Pro has 4 modes of locomotion: differential drive, Ackerman, omnidirectional, and track-based. All these features make Limo the perfect robot for learning and teaching robotics with ROS. You can even add a robot arm and study autonomous mobile manipulators for a small price. During the Robotics Developers Day, you can find a big discount buying one right now on the button that appears at the bottom right side of the screen. Buy one now and get a 20% discount.
All right, guys. Here is how the challenge works. First, we're gonna share a link with you of a ROS project through a link that we're gonna share through the chat. So let me do that right now. Okay. So in the chat, you should be seeing a link that I posted, Rodrigo Gonzalez did, and click on the link of that chat. You guys have to be paying attention for this. And this will get you a copy of the project that will allow you to participate in the contest. Once you have copied it, press the run button on the top right. This will open the project. After opening the project, you will see the rules of the challenge open automatically. What you need to do is follow the instructions and solve the challenge at any time during the conference. The challenge is very easy. Move the limo robot from the start location to the go location and use the robot camera to take a picture of the wall in front of the end location. So if we scroll down a little bit here in the screen, we're going to see some pictures. There you go. So that's the environment. This robot starts at the bottom there, and the start location has to go up to the go location. Of course, avoiding the walls, not crashing into anything. You can use the simulation that it's provided in there to develop it. And once you have solved the project, send us an email with a link to your project to info@theconstruct.ai. Again, that is info@theconstruct.ai. This is also in the instructions you'll see. And the subject has to be, in all caps, Limo Challenge. That is Limo Challenge. And out of all of these projects that you guys will send, we're going to randomly pick one to actually test it on the real limo here, on the real environment that we have in here. And if the code works on the real robot, then you win the robot.
All right, so take the time to refresh yourself and enjoy the robot contest. We will see you be back in here in 15 minutes.
And let the robot games begin.